Start. So good afternoon, and really we welcome all of you. Danny and I welcome you, all of you, for this really important event. Uh, I think we see a lot of familiar uh, names. We're not seeing everybody's faces, but we really appreciate you taking time to join this event. We know that you have a lot of other things that you could do, but it means a lot to us. And Danny is going to talk about a very important topic today. So before I introduce him formally, I think, as you know, that SPTC, got funded by the US DOT as a regional university transportation center. US DOT received 234 proposals, and they funded 34 of them, 34 of the proposals, and we are one of the regional centers. So this is a great opportunity, for our region, for Oklahoma, for OU, and all of our partner institutions. So as part of this, I think we'll be actually doing this type of event more regularly. So please suggest topics. Whatever topic that you want to get covered, I think we'll make sure that we try our best to do that. Also, you will be receiving 1 hour of PDH. I know I sometimes struggle to actually see whether I have enough. So you might be also struggling at times. So this is a free PDH, and you will be receiving one. If you do not, if you have any difficulty or if you don't receive, please let us know. You can send me an email. You could send an email to Michael, and we make sure that that the PDH is issued. It is, you receive it through online. So Ellen, one of our student worker, actually does that. Also, please mute yourself. And any questions that you have, please use the chat box to put your questions, ask your questions. And at the end of the presentation, you will have an opportunity to either ask questions by putting your questions in the chat box, or you could actually, ask, just unmute and ask questions, of course, one person at a time. We again thank you for everyone. I express my sincere thanks to all of you. I see a lot of familiar faces, and this would be a great opportunity. So Danny is going to talk to us today on longitudinal joints in asphalt pavements, best practices. I know that this topic has been, this problem has been there for a long time. And this is an extremely important topic. It's not going to the moon, but I think fixing problem, real problem. So, and Danny, of course, most of you know Danny. I think he is, known nationally, for his work. So he's a deputy director of engineering, at the Asphalt Institute since 2022. Previously, he served for 13 years as AIA's Asphalt Institute Southern Regional Engineer. He earned his civil engineering degree from OU in 1985 and has been a registered professional engineer since 1990. He had a diverse career. I think you know that. So he worked for industry, he worked for agency, he worked for academia. In fact, I can tell you all that we would not, in the very early stage of our asphalt program at OU, Danny was he was extremely helpful. We could not have, done this without his help. And also, we're grateful to a lot of people, but Danny has been one of those that really always we know that we could count on his help. And the other person that it makes me remind is Secretary Ridley. He was instrumental to starting program. Many of you that I see your name, so I don't want to be selective, so forgive me if I don't mention your name. But I think we have come a long way, but we still have a long way to go. So Danny worked for ODOT, for 20 years. He was the ODOT bituminous engineer. He spent 4 years in the industry in the materials division for Bros Construction Company. And then also, as we mentioned, that he worked for OU College of Engineering. So with that introduction, Danny, we have 97 people attending. So it's a great attendance. So please go ahead and you have about an hour to present your work, and we'll have enough time for everyone to ask questions. Thank you all.
Very good. Well, looks like we need 3 of you to call your friends to make it an even 100. But we won't wait until that even 100 comes about. So hopefully everybody can see the screen, and we'll get started talking about longitudinal joint specifications and construction best practices. So when we think about the problem, and I'm going to minimize that so I can see my whole screen, we'll talk a little bit about just what kind of problems we see with longitudinal joints. We'll talk a little bit about how specifications come into play in this issue, what we can do design-wise, placement-wise, compaction, and some other options. So certainly the idea of best practices for longitudinal joints is not strictly a contractor placement issue. There's lots of different components to getting a good quality joint, and we want to talk about several of those. So let's look at the problem. When we look at the picture on the left, you can see a road that looks like it's in really good shape. This road is several years old. Out in the middle of the lanes, everything looks fine. The problem is I've kind of doctored the center line. And so if I click the graphic out of the way, you can see that what otherwise looked like a very good quality roadway now looks like it needs maybe even some rehabilitation work. With a severe crack at the longitudinal joint, water is going to get into that joint, cause lots of issues. And so when we think about longitudinal joint problems, it's not just an agency problem. It's not just a contractor problem. It's also a traveling public problem. The mantra of get in, get out, and stay out. I think we want to do our best for that. And so a pavement that might last 20 years otherwise, if the longitudinal joint fails in 6, 7, 8 years, now we're going to have to go back in, throw up barriers, cause traffic issues, so forth. So, it's important for the DOT program costs. We have a finite budget. And we don't want to go back and fix problems that we don't need to. Of course, the asphalt industry, it's their livelihood. There's a lot of push around the country about life cycle cost analysis. And if my entire roadway is very capable of lasting 20 years, but my poor joint, cuts that in half or more, now that's really going to affect my alternate bid competitiveness. And so I think it's in everybody's interest to build good longitudinal joints. Well, we're going to use some terms this afternoon that we kind of want to get a handle on. And I want to just kind of make it known that I don't always use exactly the precise term. A lot of times when myself or somebody else in the industry uses the word density, which is really a weight per unit volume, we really intend to be referencing the percent relative compaction. So I might say 94% density. And when I say that, I mean 94% of the maximum theoretical density. And so just be aware of that I'll be using the term density consistently or a lot, but a lot of times I'm going to mean percentage of maximum theoretical. So just so happens the very next slide, though, this density actually means density. You see this graph on the y-axis, we have nuclear density in pounds per cubic foot. And probably should just say that's a density as measured by a nuclear density gauge. And then we have on the x-axis a kind of the roadway width. And so at 0, I'm at one edge on the unconfined edge. And then I go over to the supported edge, and then the next mat over in the cold lane. And so what we typically see is the highest density would be right in the middle of the mat. And then the next highest density would be lower than the middle, but over on what we would call the supported side or the confined side. And that's where we have a new mat placed right up and against an existing mat. And so we see our better density there because of that confinement allows better densification. On the far left, we have the unsupported edge or the unconfined edge where there is nothing to place the mat against. And that's where we typically see the lowest densities. Kind of an interesting slide here. We see a lot of times where we think we've got great density here. All these densities are over 93%. Certainly, we'd like to even see 94 to 95% mat density, but at the joint, at those same locations, the best we could do on the binder course, 90.5%, and as low as 87.8% at the joint in the surface. So this is data from Pennsylvania DOT, but I don't think you would find that it's very different from density information that you'd find around the country. All right, Tony Kiefer, I told you you'd see a picture of yourself in this presentation, and there you are in all your glory. This was a picture on a brand new pavement, never open to traffic, and got called out there because after a rain, you can see that at the joint, there was a lot of moisture that hung on for days and days. And what the issue was that was very permeable there, and it was permeable because there was low density. And so when we first thing I asked to do was to see the records of the densities, and station after station after station, I'm seeing 93, 94% density, but that's out in the center of the mat, not at the joint. And I'm going to show you later on in the presentation the densities of the cores that we cut right next to that joint. Pretty shocking. And so like I say, it doesn't even have to be a pavement that's aged a decade or so to have a failing joint. Here, this one's never been open to traffic and already having some joint issues. Some really interesting work we did at the DOT back when I was there in 2003 to address this density issue that we saw. What this graph is showing is an experiment that we did in-house. This wasn't research that was farmed out to anybody else. This was just the ODOT bituminous lab. I had them make a 25 millimeter nominal maximum aggregate size super pave mix, which we'd call here in Oklahoma, we'd call that an S2 mix, I guess. And mix 1 represents if I could make that mix as coarse as it could be and still remain in spec, that's mix 1. Mix 6 is the finest I could possibly make that 25 millimeter super pave mix and still remain in spec. And then I evenly adjusted the gradations 1, 2, 3, 4, 5, and 6. And what's really interesting about this really speaks to the need for field roadway density. No matter what the gradation, if I could get at least 94% density out in the field, I don't have a permeability issue. But If you look on the y-axis, around the country, the pass-fail mark is usually somewhere around 100 to 125. Here in Oklahoma, it's 12.5. So you can see at densities below 94, if I have a coarse mix, I am well out of spec on permeability. But the interesting thing is, if I have a fine mixture, I'm given a lot of grace there because I still have low permeability, even at low density. So I think mix selection has a lot to do with good joint densities. And I think if you have a fine mix, now you already have a leg up on getting low permeability in your mix. Okay, so what's permeability? Well, if water can get in between the particles in an asphalt mixture, of course, in freezing weather, that water is going to expand and create some internal stress in that pavement. And you can see just the catastrophic effects of these pictures that I believe were taken, can't remember if that's Connecticut or Massachusetts, one of the Northeast states, just disastrous. I mean, that is a shut down the road before you have an accident type of an event. And so we really need to be careful about our longitudinal joint densities. All right, so what affects the quality of this longitudinal joint density? What's going to lead or facilitate longitudinal joint problems? Well, the way the asphalt specifications are written, the way the asphalt is placed, and the way the asphalt is compacted. And so this is both an agency and a contractor and an inspection issue. Everybody's got a part to play in making a good longitudinal joint. So let's talk about the specifications. One of the things that I think is really important to good longitudinal joints is a longitudinal joint specification. I think I really agree with this statement. If you can't measure it, you can't manage it. And so we want to have some way to measure that longitudinal joint and compare it against some desired specification so that we can manage the quality of that joint. Otherwise, it will not be paid attention to. So here we have up in the upper box, what happens if we don't have a longitudinal joint specification? Well, there's high agency risk of joint failure, right? And the issues that go along with joint failures. Those are both safety issues, budget issues for repairs, so forth. If there's no spec, there is no incentive for quality. Now that doesn't mean, I mean, we've got great contractors in Oklahoma. That doesn't mean that they're going to try to do a bad job. It's just that they don't have any financial incentive for sure to make the best possible joint that they can make. And remember, we're in the low bid system, and so a lot of times even the best intentions we can't necessarily follow through with because we have to compete against other contractors. And so if we can't get a job, it makes it very difficult to stay alive. Well, the next step towards maybe where we want to be would be some type of a method spec where the agency says, this is how you're going to build this joint. And it's a one-size-fits-all type of a specification. The agency now assumes some risk because they've said how to build it. The contractor assumes some risk because they have to build it according to the specification. But again, there's no incentive for innovation because the agency says this is how it's going to be done. We have some very innovative people in the contracting industry, and a lot of times they can do some things that we just didn't think of. And so we'd like to leave room for some innovation. Of course, anytime you have a method spec, now you have to have some type of on-site oversight to make sure that method specification is being followed. Well, I think where we would like to be around the country is some type of longitudinal joint density spec. That is not this is how you do this. This is not a recipe. This allows the contractor to just say, we want a certain level of density, and the contractor now has the freedom to achieve that density in a way that they deem to be best. And like I say, they can come up with some very good ways to achieve that if we give them the freedom to do it. And so that balances the risks. Typically, we would want to include incentives and disincentives. And so if I'm a contractor, I'm after that incentive money because that's going to make me more competitive to win a bid in the first place. And so I'm after that incentive, and that means I really want to pay attention to that longitudinal joint, build a good one. Maybe my specification has some triggers that if it's over a certain amount, I get a bonus. Maybe it's just a 100% pay if I'm in a certain range, and maybe there's some type of a pay deduction if it doesn't reach a certain level of density, and maybe it requires some ceiling or overbanding or something if it's below a certain density. Want to pay attention to our city friends that might be using DOT specifications. When we have these high density specifications, joint density specifications, those types of specifications aren't really appropriate for neighborhood cul-de-sacs, places where you can't get a nice paving train in there, compaction train to do the work. And so it's going to require some judgment to decide where is a density spec like what we're talking about appropriate to be used. I'm going to see if I can minimize this as well. Pardon me. We might have some tiered specification. For small jobs, maybe the contractor just follows a method spec or submits some type of a compaction plan that has to be approved. And so that might be more appropriate for the city, county type jobs. And then for a larger interstate job, a state highway system job, or even a very large city collector, where you could get statistically based samples, then the contractor would follow this density specification with incentives and disincentives. Okay. Pardon me, but I'll make sure what slide I'm on. The controls are hiding my titles. Okay, so joint performance versus joint density. We have Stacy Williams over at the University of Arkansas has done some research, and their research indicated that when they just in the field noticed that they had good joint performance, that joint density was within 90% of the mat density. When they just had kind of fair joint performance and they checked the joint density, that was 93 to 97% of the mat density. Now, I'm not talking 97% density or 93 to 97% density. That's a percentage of the mat density. And then poor joint density when the joint density was less than 93% of the mat density. We have some more research done by Dennis Morian over in Nevada, where they basically had two categories of basically significantly better joint performance, 12 years or more, when the joint density was 98% of the mat density, and then they tended to get 8 years or less in service quality when the joint density was within 95% or less of the mat. And so in general, when we're talking about these, I gave those numbers as percentages of the mat density. So let's translate that into percent of GMM. We would typically see good performance where we would have 92% or more joint density, 8% air voids or less. We would see fair performance when we're in the range of about 89% of GMM, 89% of the theoretical maximum density, and then poor performance where we're down 87% density or less. Okay, so Asphalt Institute's suggestion for a density spec is to cut cores directly over the visible joint for a butt joint, or in the middle of the wedge for a wedge joint, giving a 50-50 split of material. So you'd average the GMM for both lots. The criteria would be greater than or equal to 92% of GMM for the joint density. That's where the contractor would earn the maximum bonus. And then between 90 and 92%, they would get 100% pay basically at 90, and then a prorated bonus as they approach 92. But if they were in that range, maybe they would need to overband the joints or surface seal the joints to prevent moisture from getting into the pavement. And then if there was less than 90% density, you would earn reduced payment, and then you'd be required to overband or surface seal the joint. And the note to the right there is, again, just this would be appropriate for highway work, large volume roadways. So when you've heard me mention the term overband before, this is what this is. I believe this is a contractor, Lindy Paving in Pennsylvania, and they overband their joints regardless of whether or not it's a pay item, which is a very interesting quality for a contractor. They do the work whether it's required or not, because they're such big believers in overbanding that joint, and that just protects the pavement from water infiltrating into the pavement system. Okay, so let's talk about some of the design issues. We've talked about different types of longitudinal joints. The most common one by far that we see here in Oklahoma is the top one, the butt joint, the vertical joint. So we tend to have a reasonably vertical face, and you can see kind of the odd shape on the right of that initial joint. You tend to have low density in that area. And then when you come back with the second mat, you overlap that other mat by an inch or so. The FAA and Department of Defense in the P401 and the UFGS specs require that loose area to be cut back during field construction and remove all of that loose material. So now we have a good solid joint there to pave against, but you still overlap that joint. The bottom one shows what they call a notched wedge joint. Very important to note that it's not just a wedge joint, but it's a notched wedge joint. We have notches at the top and the bottom of the wedge to provide some confinement when that second pass mat is placed. If it was just a wedge, that second pass would want to crawl up that slope, and you would have very poor density there. But those notches are what allows that confinement and to get good density there. And that wedge can be anywhere from a 3-to-1 or a 12-to-1 slope, depending on the thickness of the mat and the template that's used on the paver. Well, I took this picture on my way home from work one time when I was working at the DOT. A lot of you have driven this road many times. Can't remember the name of the north-south street, but as you turn south off of, I think it's 13th or so, you see this longitudinal joint, and it's right in the middle of the wheel path, the absolute worst place it could possibly be. And so why is that? Well, I think there was probably not a pre-construction conference held on this job, or if it was, this was not a topic of discussion. I think if you measured from the curb and gutter section to the from one side to the other, that joint would be right in the center between those two curb and gutter sections. And why the joint is there, as you'll notice on the right side of the screen, there's a bike path. And so the yellow lane markings got shifted over the same distance as that bike path on the right, which caused the longitudinal joint to be right in the wheel path. And so you could imagine how easily a specification detail or a pre-work conference or something could have solved this issue to avoid having a joint right at the wheel path. Another thing that we typically do, and we have a specification for this in Oklahoma specs, and a lot of states have this requirement, is when we have multiple lifts, that longitudinal joint needs to be offset, maybe 6 inches, 8 inches. I think I've seen of even up to a foot, with the idea that top joint would wind up close to the center line of the pavement. And so that's drawn out on the plans to make sure that you don't get a joint in the wheel path. We also would like to avoid having those joints right where the striping goes. And so this doesn't look too bad right now with the stripe there. But if that joint opens up and needs to be sealed, now all of a sudden at night, it's going to be really hard to see that joint. And so if that joint had been offset a little bit from the paving stripe, we could have maintained safe painting on the roadway and given that good visibility at night. Delaware DOT, we got this slide, or this copied one of their specifications for this slide. One of their standard drawings in the, I wouldn't say a standard drawing, but a plan drawing, is that they specify in their P&P sheets exactly where those longitudinal joint stripes go. And you can see that they are not right on top of the joint. On the white stripes, the two on the right, the white stripe is just to the left or to the right of that joint, and it's laid out where that joint is not near the wheel path. And so that's a good example, I think, of planning a lot of the details about the joint. One, keeping it out of the wheel path. Two, keeping the stripes from being right on top of the joint. So let's talk about the placement of that joint. We said on the initial mat, the first mat, we're going to wind up with an unsupported edge on both sides of the mat, unconfined edge, and we're going to have a really low density area on the right there. But when we come back with the second mat, then we're going to be confined, and we want to overlap that mat. And of course, anytime we've got to have sufficient material for roll down. It's going to be really important, as we'll see later in the compaction process. We don't want to starve the joint of material at that important juncture, because we could, when we compact it, the second mat, we could bridge that area right at the longitudinal joint, where the one edge of the roller would be on that cold and unconfined side, and then the other edge would be out, the drum width away from that. And then if there's not enough material right there at the joint, you wouldn't get any compaction at all. So we want to have plenty of material right there, and we also want to have this overlap. And we'll see some pictures of that coming up. If I had my choice, I would do echelon paving every time, because when I put two hot mats together, and then roll that, you will not be able to tell that there's a joint there. You're going to get great density. The density at the joint is going to be every bit as good as the density anywhere on the mat. And so, you know, in an ideal situation, I would be doing echelon paving. Problem is, I'm not always in an ideal situation. Here we have a DFW airport, really nice slide from one of their runway construction jobs. This was, I think, either 2 or 3 summers ago. But you can see 1, 2, 3, 4, I believe, pavers wide, and they are just going down the you know, a good portion of the width of that runway. And then when the rollers hit those hot joints, it's going to be really a good joint. And so here's a picture. It looks like it's kind of a fake setup picture, but there is a joint there in between those quarters, but you just cannot see where that joint is because both mats were hot and then rolled. So problem is, though, that we have traffic and we can't always reroute the traffic to a different set of roadways and completely close down the road. A lot of times we have to maintain traffic through the job, and therefore we cannot pave in echelon. I would suggest, however, that there are times where we could pave in echelon and we just don't think about it. And maybe on the agency side, if we know that we're planning on rerouting traffic and we're going to have that road to ourselves for a little bit, that it might be a requirement to echelon pave if it could be echelon paved. I think we'd get a lot better joints. Okay, well, here's a couple of pictures of the notched wedge joint and the butt joint. We saw the kind of the stylized drawings earlier, but here is the notched wedge and the butt, where we have the end gate is down and this material goes right up against that end gate, and then we have a template that forms this notched wedge. And so here's some information from Pennsylvania DOT, where they gave the option for the contractors to use either a notched wedge or a joint or a butt joint when they first started implementing a longitudinal joint spec in Pennsylvania. And so for the first couple of years, there was kind of an even mix of notched wedge and butt joints. But you can see there that they tended to get maybe 1% more density on those notched wedge joints than they did on the butt joints. And so most of them switched to the notched wedge joint, pursuing that density specification that was in place. And so you can see here's a plate compactor to help get density on that notched wedge. I've seen little rollers, drag along rollers that go right along that notched wedge. But what we think probably happens is that material on the notched wedge is thinner. It probably cools a little bit quicker, and therefore it adds a little bit of confinement to that unsupported edge even. And then when we come back with the second mat, put hot mix over that thinner notched wedge, that it reactivates that mix to some degree and gives you a better hot joint there, but don't know for sure. And I had heard that even some of the contractors that went to the notched wedge for whatever reason switched back to the butt joint. So I think I don't think it's a clear message that the notched wedge is always better, but at least for a while in Pennsylvania they seem to get better results. I talked about that notched wedge having a little bit lower temperature and therefore providing maybe a little bit more confinement. You can see out in the mat, it's about 283 degrees Fahrenheit. and the on the notched wedge we're down a little bit less than 260, which kind of makes sense if you know that wedge is a little bit thinner. Well, we want to try to help with permeability. That's what these painting the sides of the joints do. Painting the sides of the joint does nothing for the density. It just helps prevent water from getting down in the joint. And so, coating that with an emulsion, that's good. If you coat it with a PG asphalt, we think that's better. And then they also make some joint adhesives that might even be best. In recent years, in Illinois, they've had what they call a VRAM generic name, J-band for the brand name, a binder, a strip of binder that is placed down before the mat, and then that binder material wicks up through the joint and provides really good resistance to permeability. And so there's all kinds of things that you could do to prevent permeability. Another thing that we recommend as a best practice is when you tack that roadway, make sure that it's tacked wider than the width of the mat that you're going to place. That material, hot material right there on the unsupported edge. You probably, if you've been out on a roadway, sometimes seen that edge kind of creep out a little bit. And if we had some tack coat there, that would provide some additional confinement to help that unsupported edge keep from having that lateral movement that you see sometimes. Of course, we want to drive straight. That's a really critical thing to build a good quality longitudinal joint. And so you can see on the left a string line reference to drive straight. A lot of contractors use the skip paint. Maybe if I am placing a second mat or I'm in a curb and gutter section, I might have a little device here with a chain reference like that. Something for that paver operator to drive a straight line so that we can come back and match that joint. And so, this says great results. I think we already saw the string line. This is the same job with the string line, and we have a really nice straight edge. What I don't think is so great is I don't see any evidence of the tack coat extending out past the edge of the mat. And so we're not getting any confinement that way, but at least it's a straight line paving, and it's going to be easy to come back and not just match, but also overlap consistently. Here you can see a curb and gutter section using the chain as a reference, and you can see the paver operator looking here on the picture on the right, down the edge of the paver to that chain to make sure that he steers straight. So if you have a situation like this where we have not a straight edge, it's going to be very, very difficult to come back and place another mat right up against that. My joints are just about guaranteed to be poor quality. And so you may have heard me say this before. We were giving this presentation in another state, and talking poorly about this picture on the right and how poor of a job it was. And a guy came up to us afterwards and said, "That's my job." I remember that, so it was. You got to be careful not to badmouth the work too much. He didn't see. He knew it was a bad job. He wasn't upset, but he just wanted to let us know that was his job, and that he wasn't happy about it either. I love the sign there, uneven pavement, definitely uneven. So what we would like to see is this 1-inch overlap, unless I am on an airfield where I might want to only have that overlap at a 1/2 inch. And so why do we say that? Well, we'll see a picture coming up soon that makes that clear, but we're going to get more density better density with this overlap than if we try to just match up the second mat with the first. I call that the kind of the pretty joint if I don't have any overlap, and it looks really nice on day one that there's, it's just they're even there, it's nice and black, but very soon that joint is going to open up and start to receive water, and then it's going to deteriorate quickly. If I have the overlap, it's not going to be pretty. In fact, unless you train your inspectors, when they come and compact this overlapped mat, there's going to be about a 1-inch wide strip of crushed aggregate there that may make it seem like there is a problem with that. But that crushed aggregate right there on the overlap part, that's just going to slough off. And we're really going to wind up with a much better density on the second mat. So why do we say this? Well, these are pictures from Pennsylvania DOT with cores cut right over the joint. The top two pictures, those are what I call the pretty joint, where there was no overlap. They just tried to match perfectly, and it looks great on top. But when you turn it upside down, you can see very poor density there at the bottom, whereas the ones where we had the overlap, you can see just obviously without even measuring the density, much better density when we have that overlap. And so I'm a big believer in the overlap, and so when we do that, we will have this this crushed aggregate strip, but it's going to be small. And I'm going to trade a little bit of aesthetics for better performance, and I'd certainly be willing to do that. I'd like that end gate to be placed flat on the existing surface and the material flowing right up against that end gate. A lot of times you'll see that end gate riding up on top of the mat to be placed, and then that just lets the material flow under the end gate and gives me more of that that uncompacted low density material that I don't want. Sometimes you'll see a paver going down the roadway with just a bunch of material just rolling out by the end gate. So we suggest to have a confinement tunnel with those to let that material move out to the end gate and not just roll and segregate out there on the edges. And so we think this is maybe as a result of when you get these big masses out there by the end gate that just roll along, get a kind of a segregated looking mat. We said that we want that second mat to be at least 1/10 of an inch higher versus the cold side. New Hampshire has it in their specifications. It's got to be at least 1/8 of an inch higher. The deal is that if that mat is starved in that location, the roller drum's going to bridge onto the cold mat, and then we won't get any densification at that joint. And like I say, I'm going to show you some kind of scary looking data when we had just that situation occur. It might have occurred here. We have a situation where this was on the left, maybe the first mat, and then on the right is maybe the mat that was butted up against it. We starved material, and it's after a rain, which is a great time to see segregation and low density issues. And we've got that here at some places along the longitudinal joint, and we're going to have some problems there. That's a guarantee. So we want our loot people ideally to sit and chat with each other, but at worst, maybe just bump the extra material off and give you a little bit more material to compact right at the joint. Most of the time, however, there is not the discipline to do that, and they will push that extra material out onto the mat, starve the joint there, and create a poor density. And so you certainly don't want them slinging that material off across the mat. I know when I first started at the DOT, For some reason, that really impressed me that those lute operators really knew what they were doing, and they were just working hard, throwing material across the surface of the mat. Only in later years to find out that that's probably really not a good idea and is going to wind up with a rough surface and poor joint density. So I love the picture of the guy on the right. That's what I remember some of the ones on my initial job, just not only just throwing it across the mat, but this guy's obviously enjoying it. He's got a smile on his face, throwing that material. Okay, let's talk about compaction. Of course, just for good compaction, we would like the roller drum to stay up close to the paver. Density is obtained when the mat is hot. And as far as on the joint, when we're on the unsupported side, we've got a couple of options, main options. Option one is to let that roller overhang the edge 4 to 6 inches on the first pass. Option two is to bring that roller 4 to 6 inches from the inside of the edge, and then the second pass go over the edge. And so option one, as long as that edge can support the roller without breaking down, I think that's probably the best option there. The idea behind option two is that we would densify the mat and therefore provide a little bit of confinement and minimize lateral movement under the roller at the longitudinal joint. And I understand that. The issue that we see sometimes is if we make that first pass inside 4 to 6 inches, the pavement edge, we might get a stress crack right there. Going to sometimes not easy to see. And so that might cause some long-term damage. So our recommendation at the Institute is to allow that first roller pass on the unsupported edge to hang over 4 to 6 inches. Now, what, versus this option number two of staying back 4 to 6 inches and then rolling. And we've already talked about this potential for stress crack, even though we might minimize the lateral movement. Well, on the hot side, again, you've got a couple of options. Our recommendation is kind of the opposite of what it was for the unsupported edge. This one we would recommend coming in about some number of inches, 6 inches, 12 inches, maybe even up to that with the first pass. And then the second pass, now we can use the full weight of that roller drum to drive this wedge of loose material between the cold side and now this initially compacted hot side, and get a nice wedge of density right there at the joint, making sure on that second pass to overlap the cold mat at least 3 to 6 inches. So if we just make our first pass with the edge of the roller on the cold side and the brunt of the roller on the hot side, if I starve material on the hot side right at the joint, you could see that I could just support the roller on the cold side and then lay out onto the hot side and not get any densification under most of the roller. That's a real problem. Now, I told you I've been kind of teasing this data, and this was on the same job that you saw, Tony Kiefer, myself, I think Reynolds Tony was out there, Rick Bond was out there looking at that wet joint. And we cut some cores on either side of the joint, and those are some scary numbers. One core there, second lift on the base on the right, was at 93.4 at the joint, great number. But look at those numbers at the surface and intermediate layer on the left, 82.6, 83.3. That is very, very low. It should come out from under the screed at that density or more. And so I don't think we got any densification from the mat. And I think we got that situation where the roller was supported on the cold side and we just starved material there at the joint and got no compaction, and we see these extremely low densities that will cause some real problems. Okay, so we want to watch out though when we make that first pass still on the hot side. You can still see on the picture on the right evidence of some stress cracks, and so keep an eye out for that. If you have those, then I would go with the other option. But you know, that being said, there's not just one prescriptive way to roll the longitudinal joint. You have to look at it and realize that there's pros and cons, and make your best judgment for the project. Okay, so about done here. Other options that you might have. If I want to have two supported edges and no unsupported edges, I might mill and fill. That's what this mill and pave one lane at a time is. I mill out one lane, I come back, and now I've got supported edges on either side, which I'm going to tend to get better joint density that way versus having an unsupported edge. The cut back joint, that's again what they do on airfields, both FAA and military, Department of Defense airfields. Some places have used these joint heaters, which the original joint heaters, I don't know, were very effective. But I think the newer joint heaters can heat up that cold mat that you're placing up against and give you a much better joint. So joint heaters are not for the unsupported side, they're for the supported side. Joint adhesives, again, those will affect, they might improve the impermeability that we want at the longitudinal joint. So hot rubberized asphalt, the VRAM, things like that would help that. They won't really change the density, but the permeability is a significant issue. There are some states like Tennessee that puts like the equivalent of a Thompson's water seal for a wood deck. They would spray some type of a sealer right over the joint, and it kind of sheds the water. And I believe in Tennessee, they do that pretty much as a matter of course over a certain types of roadways. Rubber tire rollers on the joint have been shown to optimize getting density at the joint, where you might have some bridging issues with the steel wheel roller. If I have a pneumatic roller, I don't tend to get those same issues. Warm mix asphalt, certainly, I believe most of the pavement placed here in Oklahoma is at least warm mix asphalt by some technology. Now, it's not necessarily placed at warm mix temperatures, but it's a compaction aid. The material tends to be workable and compactable for a longer period of time, thereby giving us better density. Certainly intelligent compaction has come a long way over the last several years, and there's a lot to be said for that type of technology. So this is what we want. Last slide. This is I can't remember how, 14-year-old project. This is in Indiana, I-65, 12 inches of hot mix asphalt over rubberized jointed concrete pavement. It's a warranty project. 14 years old, that joint still looks great. The mat looks great. That's what we want to build all the time. And I think that we can do that. So with that, I am happy to take any questions that you might have. We can, maybe I can open up this chat. Looks like there might be some discussion on the chat. So let's see.
So Danny, I think we have some questions. I don't know whether those questions are posted to everyone. Yeah, I think those first two were posted to everyone, so you should probably also be able to see. And then I have some additional questions that I have received. But before that, thank you for the wonderful, wonderful presentation covering a lot of ground. So if you could actually go over those, the one that you can see, and then I have some additional ones.
Very good. Well, so I think there's just maybe some conjecture here by Uriah Nichols about not having room to to keep a lane open. So I think that's probably on the Oklahoma City picture with the joint on the in the wheel path. That could certainly be the case. I'm not familiar with the project work, just the final picture of that that joint in the wheel path. I see Ginger here asking, do we necessarily need to have the wedge? Could we have the notch at the top and the bottom and have just a flat section? I have seen some notched wedges that look pretty flat. I'd have to think through what might be the issue with that, and whether or not that template would still work right and not give you any kind of a stress crack at the top notch. So great question, Ginger. I try to be honest and not answer to be answering if I don't know for sure. And I've got to say, I don't know for sure about that. So Uriah, questions about research being done on the effectiveness on a joint with poor density that was sealed, and in an effort to improve impermeability. Did the joint still fail early due to low density surrounding the sealed joint? I am not aware of any specific research that I could point to. I would certainly recommend speaking with somebody. Like I know Tennessee DOT does a lot of that, and so they might have something like that. If you contacted somebody at Tennessee DOT, and I know I saw Ken Hobson's on here. I can't think of the guy's name at Tennessee DOT. Mark. Can't think of his last name, but at any rate, he plenty of people at the Tennessee DOT that might be able to help with that. And I think Mississippi also does some sealed joint work that might be able to answer that type of a question. So Uriah, I can't answer specifically of that. And then we have B. Simpson. How many of these states use salt and sand for bad weather as we do? And do you think that has any issue with the joints as well? I think absolutely. Anytime you have an open material where anything could get in, whether it's, we're a windy state, silty sand can blow into those joints. Certainly water getting down into those and freezing. We don't have a big freezing issue here in Oklahoma like the other states do, but it does get cold enough to freeze water inside the pavement, even if it's not a significant portion of the time, that could do some damage. So as far as I know, every state uses salt or sand or something. Now, there are a lot of states that are using this calcium chloride spray, and I don't know if that has any of that same type of effect for this just liquid, but most of the states certainly would use that. Doug, good to hear from you. Are you aware of stats on what percentage of longitudinal joints fail if they are properly constructed? I don't have them in front of me, but an earlier version of this presentation for a 4-hour workshop had statistics in Pennsylvania DOT. We had their data where I think they implemented the longitudinal joint specification correctly. They met agency and industry, said that this is coming. They outlined what they thought they would do. They had a shadow specification for a year, maybe even 2 years, to let the contractors kind of experiment how they were going to try to meet this joint specification. And then they gradually added the bonus and deducts. And Pennsylvania DOT did show increasing density on the pavement each year. And that was also followed up with your question about if we got that good joint density, how long did they last? Unfortunately, Doug, I can't cite that off the top of my head, but just a feel for that. I think when we have good joint density, I think you could expect, well, we saw the Indiana picture there where the joint density at 14 years, or that the joint looked as good as the mat. So I think with good joints, you can expect density performance or joint performance to approach that of the mat. And then we also see from experience joints failing as early as a couple of years, decent densities going to about 8 years or so. Stacy Williams at Arkansas, University of Arkansas, I believe would probably have some data on that as well, because I know they've done some research. So those are all the chats. What else?
Yeah, so Danny, if you could sort of stop sharing, then we can bring the other screen back.
Okay.
See everyone. And so before I actually read the other questions, I just want to thank you again, and thanks to everyone. And if you really want to see other topics, please just let us know what we could do to help. I don't have the very specifics, but Dr. Fuji Zhao from TTI would be also making a similar presentation. He does very, very practical work. So this is wonderful. So some of the other questions I have, that could you cite some state, and you already mentioned probably this, the state duties that do a good job in general when it comes to longitudinal joint density. And we don't want to name.
Yeah, that's a careful question.
Do as much of a good job.
Yeah. I think what I'll do is tell you that the state that I think the best, some of the best work is in Pennsylvania DOT. Let's look at that state versus maybe some of the poor states. I also, before I forget to mention it, this presentation will be posted on the SPTC website. And so a lot of times you want to go back and look at some slides, kind of just get us, remember what we talked about, and you'll have access to those on the SPTC website.
And also they can ask questions, follow-up questions afterwards as well, that everybody have your email address. Definitely. Thank you for covering that logistic, Danny, that your slides would be posted. A PDF will be posted on the SPTC website. So the other question is that any changes in the spec, longitudinal joint spec, I think you may have also covered somewhat for other type of mixes like work mix, SMA, BMD mixes.
Yeah, and so I'm not sure, I can't think of an instance where somebody changed a spec based on the mix type. I can think, we did show some slides about how the mix type affects the longitudinal joint density. Specifically, finer mixes tend to perform better, so forth. But as far as my expectation would be that if BMD, and if you're not familiar with that acronym, it's a balanced mix design. I think that could, if properly implemented, perform very well. Now, the thing with balanced mix design is that we're looking to find basically the lowest binder content at which a cracking test will meet specs, and then the highest content at which it will meet a rut spec. And so the question that agencies need to answer is, if this is truly balanced, it should be the design binder content ought to be in the middle of that. But I think the way a lot of agencies around the country are working it is that they take whatever that lowest binder content is, that it will still perform on a crack test, and that's the design binder content. So I think there are instances in balanced mix design where that binder content is even lower than what they're used to using. So I think you could have problems. This balanced mix design, great concept, but just like anything else, it has to be implemented correctly and with an eye towards field performance to make sure that it performs well. Ricky Owens talking about my favorite calculator.
Yes.
You that worked with me at the DOT know how much I love this calculator. So great for asphalt mix design work.
Anyone else would like to ask questions to Danny? Please unmute yourself. Just state your name and organization you represent, and please go ahead, and one person at a time. I see Audrey, you're sort of unmuted. But anybody, anyone would like to ask questions to? My screen does not accommodate everyone, so I just only see limited number of people. We had up to 106 people attending this event. That's a great number. So anyone else would like to ask any questions to Danny? And as he indicated, that this presentation will be posted on the SPTC website. All right, so if there are no additional questions, so we want to thank sincerely to Danny for finding time out of his very busy schedule to make this wonderful, very practical presentations. So let's give him a virtual applause. Yeah, so Danny, thank you again. And I think we also talk about some other, yeah, wonderful, that's good. So we get quite a few applause. So thank you again. And thanks to all of you, those who really took this opportunity to join, and we'll do it again. Thank you very much.
All right. Thank you, Dr. Zaman. Thanks everybody for joining us.
Thank you.